Hello, stupendous students of M3. We are here for the fourth lesson of Unit 7. This is on transformations. This is basically bringing all of the different transformations that we have done all together. So, a little more vocabulary here. A rigid transformation is a transformation that changes the position of a figure without changing the size or the shape. Which transformations have we done that are rigid? So we're looking at ones that provide us with congruent shapes that have just changed where they are located within, the coordinate plane or wherever. And so that would be the very first three that we did. The translations, the reflections, and rotations. A non-rigid transformation is a transformation that changes the size or shape of the figure. So this one does change the size. So none of these are non-rigid because the size stays the same. The one that it does not stay the same is the one that we just did in the last lesson, and that would be the dilations. All right, so we're just going to kind of apply all of these different ones. We're going to move shapes around in the coordinate plane using all the different transformations. So actually today is a little bit of a review of stuff that you have already seen. We're just pulling it all together. So it says rotate the figure at the right 90 degrees clockwise, then reflect across the y-axis. Give the coordinates of the image. Okay, so we've got to go the order that it says. We've got to rotate 90 degrees clockwise. So clockwise, remember, is this way, going with the clock. So 90 degrees would be one turn. Okay, so that tells me where, remember we ignore these numbers, and that tells me where, I'm going to figure out where the coordinates end up. So A would be at 1, -2. So, or A prime would be at 1, -2. And then B prime would be at 4, 1, 2, 3, 4. So 4, -4. C prime would be at 4, -7. And then D prime would be at 1, -7. Okay, so now let's plot those. So that will be our first transformation. So 1, -2. There's A prime. 4, -4. There's B prime. 4, -7. And then 1, -7. Just like with the last lesson, you will need your ruler or some sort of straight edge for this lesson. Okay, so that is not my final result. That's just after doing the 90 degrees rotation, clockwise rotation. Then it says reflect across the y-axis. Well, here's your y-axis. So we're just going to reflect this over here. So A prime is 1 away here. So it's nice when it's in the coordinate plane like this because then I can just count. So 1, 2, 3, 4. There's B double prime, D double prime, and C double prime. All right, so now that is my final image. So here's my original, my first image from my first transformation. I've got the prime and then the double prime for my final. So now let's write the ordered pairs. So A double prime is -1, -2. B double prime is -4, -4. C double prime is -4, -7. And D double prime is -1, -7. Is the image congruent or similar to the original? Well, to be congruent, it has to be the same size, the same shape, and this did not change size. We did not do a dilation, so the size did not change. So that means it would be congruent. And it doesn't ask us to, but if you had to, you would say A, B, C, D is congruent. Remember, that's the congruent symbol to A double prime, B double prime, C double prime, D double prime. So that's what the congruent statement would look like there. Okay, next one. Dilate the figure above with a scale factor of 1/2, then translate 4 units right and 3 units down. So we've got 2 things to do. So let's start with finding the ordered pairs of the original so that we can then take half of those values. So A is at -4, 4. U is at -2, 1. R is at -4, -2. And L is at -6, 1. Okay, so we need to take half. So that means A prime would be at -2, 2. U prime is going to be at -1, 1/2. R prime will be at -2, -1. And L prime will be at -3, 1/2. All right, so let's plot those. That will be our dilation. So -2, 2, -1. So the 1/2, we're going to have to kind of estimate where the 1/2 is. -2, -1. Oh, I forgot to label these, didn't I? A prime, U prime, R prime, and then -3, 1/2. And that's L prime. Something looks off. All right, so let's connect. Something's off because these, what did I do wrong? No. -4, 4. These figures should be, because L is at -8, not -6. There we go. Now notice, the reason I stopped is this shape doesn't look like this shape. So one of the points appeared to be off because these should look the same, right? They should be similar, so they should have the same size. So I knew one of the points was off. I just couldn't figure out where I went wrong. It was back at the original. That point should have been -8. So now this is at -4. Sorry about that. Okay, so let's -4. But that shows you why you should always take a look to make sure that your answer makes sense. And I knew mine didn't make sense. There, that looks much better, doesn't it? Okay, but we're not done yet. Now I need to translate it 4 units right and 3 units down. So I'm just going to count. 1, 2, 3, 4. Whoops, 4 right and 3 down. Man, I'm having a rough day, aren't I? So 4 right, 3 down. 1, 2, 3. So there's where A double prime is. 1, 2, 3, 4. 1, 2, 3. There is U double prime. 1, 2, 3, 4. 1, 2, 3. Ooh, it doesn't quite fit. 3 units down. Yep. 4 right, 3 down. R double prime. And then 1, 2, 3, 4. 1, 2, 3. and connect. Make sure that it appears that they are, that they look the same, which they do, so I don't think I made a mistake. Is the image congruent or similar to the original? They're not congruent because these are different sizes, so that means they are similar, and that's because I had to do a dilation. Okay, and on to the back. Now, this time you are given the two figures, and you got to figure out what happened. Describe a sequence of transformations that could have occurred to produce the image. Well, the first thing I notice is the size is different. So let's take care of that first. Look at the horizontal. You either, when you're looking at the sizes here in the coordinate plane, you want to look at either look for a vertical or a horizontal side to figure out that scale factor. Otherwise, you'd have to do Pythagorean theorem to find out what that length is, right? So let's look right here. This is 2, and then this is 1, 2, 3, 4. So it looks like I had a dilation of 2. Okay, so dilation with a scale factor. Let's be a little more precise. Dilation with a scale factor of 2. Okay, so let's do that. Let's figure this out. A, B, C, D. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So negative 5, 5. 1, 2, 3, 4. 1, 2, 3. Negative 4, 3. Negative 2, 3. And negative 2, 5. Okay, so we did a dilation, so that would mean my new points were doubling, so negative 10, 10, negative 8, 6, negative 4, 6, negative 4, 10. Okay, so let's plot these new points. Negative 10, 6, 7, 8, 9, 10. Negative 10. Did I count that right? 1, 2, 3, 4, 5, 8, 9, 10. So there's A prime. So these have primes. They're going to have to be double primes since we're doing a double transformation here. Negative 8, 6. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Negative 4, 6. 1, 2, 3, 4. 1, 2, 3, 4. And then D prime, negative 4, 10. 1, 2, 3, 4. Okay, let's connect. Oh, what did I do wrong? Oh, this was, my goodness. Lots of mistakes. Sorry about that. That was negative 1 on D, not negative 2. So now when I double it, it's negative 2. So that will make more sense. So negative 2, 10. That looks better. Okay, so that was my first transformation. Clearly, I have not ended up down here yet, but now the sizes are the same, so that's good. So now, looks like it was a reflection, right? So we've got to figure out what it reflected across. It seems like it was probably the x-axis, but we do need to make sure that the points are the same distance away. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Corresponding points are the same distance away from the x-axis, so it looks like it was a reflection across the x-axis. So dilation with a scale factor of 2, then a reflection across the x-axis. And so that would get us to land right there. So that is the sequence of transformations that would work for this. Sorry about my mistakes today, but if you have any questions, make sure you reach out to your teacher. I hope you have a fantastic day.